Hello, and good morning, Chemist. Welcome back to our Fresh Monday lesson on phase changes and changes in state. This is a fair bit of information, but I'm going to keep it relatively concise here. You'll also be able to get a copy of this lesson as a PDF if you want to read through it after. You can always come back to this video, and we'll give you some stuff from your booklet as well to all sort of come together. But we want to start by just having a little talk about what phase change means, what states mean, and what to look for, because this is kind of a cool thing in chemistry when we talk about physical changes and phase changes. What we're really talking about are changes in state. And as you know from last week, state are things like solids, liquids, and gas, and we can make these charts and track the amount of heat and the temperature that goes along with phase changes. This is something that we understand intuitively. If you take like an ice cube and put it on like a grill, it's going to melt into water, then eventually evaporate. So that's what we're going to be talking about, is exactly how these sort of phase changes work. So like water melting or water evaporating is the classic example. We have something in one state and it's going to change to another based on the amount of heat. If you want to turn water into ice, you put it in your freezer to cool it down. If you want to turn water into water vapor, you're going to put it on like a frying pan or something. Cool. So here, these are the words that we're going to use. Don't fret too much just yet, because these will also be written in your booklet and on, well, most of the slides. But we have gas, we have liquid, we have solid, and then there's go-betweens in either direction for each one of them. A lot of these words you probably already know, like you would have heard of melting and freezing. Condensation you probably heard of, perhaps vaporization, which is also known as boiling, boiling, and gas and solids have deposition and sublimation, which are kind of fancier words and less common, but in general these are things that we can kind of relate to our experience and what we understand about elements and the materials around us. So just to outline this, as we go gas to liquid, it's condensation, liquid to solid is freezing, and solid to gas would be sublimation. If we change directions here, we can go gas to solid would be deposition, solid to liquid is melting, and liquid to gas is vaporization. So these words you'll be expected to learn and remember, but as we go through this, that should be pretty intuitive. Most of them you already know, like melting and freezing and condensation. So we're just adding a couple more chemistry terms here. So here's just another way of looking at it. The same things here, but written in sort of a heat way, where we're looking at if things are heating up or cooling down. You can think of red as stuff that's heating up, heat added, and the blue stuff is stuff that's cooling down. So these are things that you can probably consider too, right? Because if you wanted to take water and turn it into ice, you'd want to get it colder. And if you wanted to turn ice back into liquid water, you'd want to warm it up. So we have the phase changes that work in either direction, both cooling and warming, with gases being the hottest and solids being the coldest, just like we were looking at last week. So phase change involves a change in energy, and it can be endothermic or exothermic. These are just saying what I was saying just then about heat, but in chemistry terms. You'll likely remember these endothermic and exothermic words from your chemical reactions unit. So endo means bringing in, so energy is absorbed. Thermic meaning like thermal, heat. So bringing in thermal energy is absorbed. Or exothermic, exo you can think of outside, like an exoskeleton on a bug or something. So the energy is released to the outside. So if we want to melt something, we have to take energy in to get it hotter. And if we want to cool something down, we have to get energy out to let it get cooler. So all this heating and cooling is an energy absorption or release. So why is a change in energy necessary at all in a phase change? We're going to look at this, but you can take a second now if you like and sort of consider that and think about it. It all has to do with intermolecular forces. This is what we were looking at the very tail end of last week. But intermolecular forces must be broken for a substance to change states and phases. So imagine you have a solid and they're held together all tight and they're very attracted in their intermolecular forces. You have to overcome these intermolecular forces. That's a key word there, overcome. to make something be a liquid. Like, you have to work on it to get it to not be as tied together, and even more so for a gas. So we go less dense, less dense. Think of particles like sort of little magnets, where solids are all the way snapped together. They attract, and to pull them apart, it takes energy. Think about if you're pulling on a magnet. You have to kind of put some work into that with your arms to get it to come apart. Similar here, we're going to have to put energy in to get it to snap apart, just like a very strong molecular magnet. Cool. These are going to be the meat and bones of this unit, are things called heating curves, which look really fancy, but they're really not doing all that much crazy stuff. They're just saying as temperature goes up and energy goes up, so you can think of a higher energy, higher temperature state over here, and a lower energy, lower temperature state over here. It shows how we go from solids to liquids to gas, and this is true for like any compound. So we don't need to say what that is, we can just imagine it as whatever compound we wish to. But the thing to notice here is that we have it as a solid right here. This is when it's in a solid state, when the temperature is low enough. Then it says we have a phase change here, melting, where it gets flat. And that flatness is very, very crucial to understanding of phase changes and what that means. So we'll talk about that in a minute here. Then we have an area where it's a liquid, as the temperature is in like this range. So like water is a liquid from 0 degrees to 100 degrees, for instance. So that's the range that something's a liquid. Then we have another phase change where it flattens out, in this case vaporization. And then we end up with a gas, just in perpetuity as temperature goes up. So we have these states in a range of temperatures. So like a solid water, ice freezes at 0 degrees Celsius. Anything below 0 degrees Celsius would be a solid. Then between 0 and 100 would be a liquid for water, and then above 100 would be a gas. But at the actual point of phase change, we see a plateau in energy. So energy must be absorbed to melt or boil. That's what we were saying before. And the temperature will plateau even though energy is still being added. So what that means is if we want to go from ice to liquid, we're gonna have to add heat, and energy is still being added all the way in here for the phase change, but we see a plateau. A plateau means the graph becomes flat. So at this point, all the added energy is used to break the attraction, if we remember back to last slide, in the intermolecular forces. So here it's meant to break an attraction, not to increase the kinetic energy. So right here, all the work and all the energy is going into breaking those bonds and snapping those magnets apart, instead of actually increasing the temperature of the surroundings. So all the energy is just going into breaking those intermolecular forces.